Welcome back to the GCSE Maths Pro YouTube channel. Today's video is a compilation of everything you need to know about simultaneous equations as a foundation tier student. So as you can see, these are the main two topics we'll be covering. First of all is how to solve linear simultaneous equations, in which we will go through two different methods. You just have to choose which one you would prefer. And then a little bit at the end, we'll go through how to solve simultaneous equations on graphs. If you would like to look at any of these topics in more detail and with more questions, I will link down below the individual videos. So first of all, the question will probably say, solve these simultaneous equations. So the elimination method is one of the two methods you can choose to use to solve these equations. So just with looking at equations in general, the bit that makes them simultaneous is the fact that whatever the x value is for the first equation is the same x value for the second equation, okay? So when I find out what x is, it's the same for both. Again, when I find out what y is, again, it's the same for both equations. The elimination method, it's kind of in the name, we're going to eliminate one of the letters first. So you're going to have a little look at your simultaneous equations. You're going to see, right, okay, we're going to focus on the coefficients of x and y. The coefficient is the number in front of the letter. So for example, 4, 7, and this is -2 and +2. These are all coefficients, right? You're going to check, do I have the same number of x's or the same number of y's? In this case, yeah. We have the same number of y's, don't we? They're both 2y. If you have that, eliminating kind of means make it 0, isn't it? Cancel it out, right? If I've got 2y and 2y, well, I can cancel those out to make 0, can't I? The first bit is you need to decide which letter do you want to eliminate. Now, this is a choice. You can choose either x or y. However, there's normally an easier option, right? So, looking at the coefficients, which ones of either x or y would be the easiest to make 0? Now, in this case, the easiest route would be to eliminate y, because they're both already 2y, they're the same quantity. Doesn't matter if they're plus or minus at this point, we're just looking purely at the number in front of the letter. So in this case, I'm going to choose to eliminate y. Step number 2 is you have to figure out, okay, well, how do I eliminate y? By either adding or subtracting the two equations. Obviously, we always take the symbol in front of the letter as well, don't we? So in this case, it's not just 2y, it's -2y, and this one is plus 2y. You might be able to figure that out just by thinking about it, or if you're not sure, there are acronyms that you can use to help you. So we have SSS, which means if you've got the same sign or the same symbol, you subtract. So if they're both plus or if they're both minus, you have to subtract the two equations. Or we've got the other one, which is DSA, which means if they're different signs, so one's a plus, one's a minus, you have to add the equations. So in this case, you can see I've got a minus and a plus, so I need to add the two equations. So I'm just going to draw a line underneath and put plus. Now, it is algebra, right? So you can only add together like terms. So in this case, I'm just going to go through column by column. So 4x plus 11x, how many do I have? Well, I've only got there 11x. Okay, now the next bit should make 0, right? That's the whole point. Minus 2y plus 2y makes 0, doesn't it? Okay, good. They cancel out. I've eliminated y. Equals, and then I've got 14 plus 19, so that should give me 33. Do you see how now I've got an equation with only one letter, just x? Again, it depends which one you decide to eliminate. You might end up with an equation with just y. That's fine, as long as you've got an equation with just one of the two letters. That's the aim. Now that we're at this point, you're just going to solve it like a normal linear equation, aren't you? So solve the equation. When we want to solve a linear equation, we want to get x or whatever letter it is just on its own, don't we? Well, the 11 is in the way, isn't it? I don't want 11x, I just want 1x. So the opposite would be to divide by 11. So 11x divided by 11 is obviously just 1x. And 33 divided by 11 is 3. Okay, perfect. So I've already got one answer here. I eliminated y to find x. X equals 3 for both equations. Once you've done the first 3 steps, the last bit is much easier. Step 4, you basically want to then take this value and substitute it back into one of your two original equations. It doesn't matter which one again, you just look at both and decide, do you know what, like the first one is easier, the second one's easier. substitute the value that you found. It might be x or it might be y, but in this case it is x. You substitute the value back into one of the original equations. So I'm personally probably going to choose, I might choose the second equation because at least there's no negatives, but you can choose whichever. So 7, now instead of x I'm going to write 3 because I know it's 3, isn't it? Plus 2y, which I still have, equals 19. This is my point. Do you see how now we've only got y in the equation? And I guess step 5, if you want to call it step 5, is to solve the equation again. Solve the equation to get y. 7 times 3 is 21, plus 2y equals 19. Okay, it's currently positive 21, isn't it? So the opposite would be to subtract from both sides. So I get just 2y. 19 minus 21 is minus 2. And then I would just need to divide by 2 because I just want 1y, not 2y. So y equals minus 2 divided by 2 is minus 1. There you go. There's your second solution, and then you have finished the question. So our answers are x equals 3 and y equals minus 1. Okay, so this one is a little bit different, only because now we're going to take a step up and make it a little bit harder. If you have a look at our two simultaneous equations, you're going to see that now we don't have the same number of x or y, for example. The coefficients are now no longer the same. Now we have to apply it to something a little bit harder, where we've got to add an extra step at the start in order to create that scenario where we do have two of the same letter. So this is where you've got another decision to make. You've got to look at these equations and go, do I think it's easier to make the x's the same number, the same quantity of x's, or the y's the same quantity? We're going to be using the concept of the lowest common multiple to find the same coefficient for one of the letters. For example, you're going to look at it and go, okay, well, currently I've got 4 and 2. Ignore the symbols, that doesn't matter, just the numbers. For x, I've got 4 and 2. So the lowest common multiple of 4 and 2, where is the smallest number that they both would overlap? Well, that's 4 itself, isn't it? And then let's say for the y's, so we've got 2 and 5, the lowest common multiple of 2 and 5. Again, if you think about the times tables of 2 and 5, the first time that they overlap is at 10, isn't it? So this is how I'm going to choose, because do you see how if I were to make both the x's the same number, I just have to make them both 4x? Well, that's great because one of the x's is already 4x, isn't it? That means I only have to change the second equation. The first equation is already 4x, it's perfect. However, if I were to look at the y's and make the y's the same, neither of them are currently 10y, are they? Therefore, I would have to change both equations. You can do either. You can make the y's the same or the x's the same. It doesn't matter, okay? It's not right or wrong. So in this case, I'm going to choose to make the x's the same coefficient, okay? So both have to be 4x. So I'm going to label them equation 1 and equation 2 again. Equation 1 is perfect. Don't need to do anything about that. I might just write it again over here just so we can look at it closer to what I'm about to do. That's equation 1, isn't it? Equation 2, how do I make it into 4x? Well, how do I go from 2x to 4x? What do I need to multiply by? Well, I have to times by 2. I can't just times this by 2 and make 4x, because then it wouldn't be the same equation, would it? I have to multiply the whole of equation 2 by, in this case, 2. So equation 2 multiplied by 2, we get minus 2x times 2 is minus 4x. Okay, they're both the same now. We get 5y times 2, which is 10y, and we get 29 times 2, which gives us 58. Now, if you want to call it equation 3, you can, it's up to you. Now I've got these two, we can kind of ignore the other two equations, okay? Now I'm back to the same steps as we took before, okay? We've just had to add in this additional step at the start, haven't we? From now, I'm going to do the same thing. So I'm looking at my 4x's, obviously that's what I'm going to eliminate, isn't it? So you have to choose. Same sign subtract or different sign add. How am I going to eliminate the x's? Well, if you have a look at the x's, and again, it's the symbol in front of the x's, right? We're not looking at pluses, okay? That's to do with the y's. We've got positive 4x and negative 4x, okay? That means different sign, right? 1 plus, 1 minus. So different sign, add. So I have to add my two equations together in order to get rid of or eliminate the 4x, right? Because you've got 4x plus minus 4x, that makes 0, doesn't it? Perfect. Okay, then we're going to add everything else. We've got 2y plus 10y, that's 12y. Then we've got 2 plus 58, which is 60. Perfect. Again, we're back to something that looks a bit more familiar again. I've now got y as the only letter in my equation, so all I need to do is solve that equation. So I have to divide by 12 on both sides to get just y on its own. So 60 divided by 12 is 5. Okay, perfect. I've done all of the hard work now. I know what one of my letters is. As we know, the second half to find the other letter is then a little bit easier, isn't it? So I'm going to bring back my other equation so you can see it. But this is where we have to choose which equation do we want to substitute the y being 5 into. Now, you can choose 1, 2, or 3. I wouldn't choose 3 because it's just a bigger version of equation 2, right? So if it's bigger, it's going to be more work. I would personally just stick to choosing between equation 1 and equation 2, okay? Just keep it simple. Whichever you think looks easier. I would say equation 1 looks easier. Not only does it have no negatives, but also the numbers are smaller, so that's just my personal choice. So sub y equals 5 into equation 1. So we've got 4x plus 2y. Now I know that y is 5 though, so I've got 2 times 5 now equals 2. Now you can see I've got an equation with just x, so I'm going to solve this. Obviously, first of all, I'm going to times 2 and 5 to make 10. Now I can see what to do. I need to move the 10 across, don't I? So because it's plus 10, I need to subtract 10. 4x equals 2 minus 10 is minus 8. And finally, divide by 4 to get x on its own. Just going to put it over here. So 4x divided by 4 is obviously just 1x. Equals minus 8 divided by 4 is minus 2. There we go. So our solutions are y equals 5 and x equals minus 2. So as we were just looking at in the previous one, we want to eliminate x or y, but neither of them have currently got already the same coefficient. So I need to choose. Do I want to make the x's the same, or do I want to make the y's the same? And that's by looking at lowest common multiple. This one doesn't really make much difference because technically I would have to change both equations whether I choose x or y. Because the lowest common multiple of 5 and 4 for x is 20, isn't it? And the lowest common multiple of 2 and 3 for y is 6. So either way I have to change both equations. So there's not a lot of difference in this one. I would probably choose to make y the same just because 6 is a much smaller number than 20 and have to multiply by much smaller numbers. So let's see, equation 1, equation 2. I'm going to make y the same, okay? So equation 1, I actually have to multiply to make 6y from 2y. I have to multiply everything by 3, don't I? So I get 15x plus 6y equals, and then 23 times 3 as well, which is 69. You can call that equation 3 if you like. And equation 2, I need to multiply by 2, because I've already got 3y, I want to make 6y, times it by 2. So 4 times 2 is 8, obviously 3y times 2 should be 6y, and 10 times 2 is 20. Okay, let's call that equation 4. So now I go, right, okay, I've got my two equations. At this point, I'm kind of ignoring both of the original ones, aren't I? Because I've changed both. I've got the same number of y's, perfect. Now, how do I eliminate them? Do I need to add or subtract? Well, same sign subtract, different sign add. So they're the same sign, they're both positive 6y. I have to subtract. So again, go through in columns. 15x minus 8x is 7x. Obviously, 6y, take away 6y is 0, that should cancel out. And 69 take away 20 is 49. Okay, perfect. I've now got an equation, 7x equals 49. I solve that. In this case, I'm going to divide by 7. So I've got x equals 49 divided by 7 is actually 7, isn't it? I've got one value. The hardest bit is done. Now I'm going to sub x equals 7 into, now this is where you choose an equation. I would personally choose one of the original two because they're smaller versions, but it doesn't really matter, whichever you prefer. So let's see, which one do I prefer? There's not really a lot of difference, is there? Let's go with equation 1. So we've got 5 times 7, 5x, 5 times 7, plus 2y equals 23. I'm going to multiply this, obviously. 5 times 7 is 35, plus 2y equals 23. And I'm going to subtract the 35 because it's currently a positive, so 23 take away 35 is minus 12, isn't it? Make sure you remember which way round you're subtracting. We're taking away the one that we're moving. So 23 take away 35. And then I just need to get y, so divide by 2. Minus 12 divided by 2 is minus 6. So you can see the second bit's always much easier. Once you've already got one value, the second value is pretty easy to find. You just have to kind of fight through to get the first value, right? So those are my answers. X is 7, y is minus 6. Okay, you can kind of start to get a rhythm of this, and it starts to get a little bit faster as you work through more questions. Okay, so we're going to see linear simultaneous equations similar to the ones that we saw in the first video. We're just going to be using a different method. When you have substitution method, you might see it laid out a little bit differently. Okay, so in this case, we've got y as the subject of this second equation, right? It's still effectively the same thing, right? They've just rearranged the letters. If I were to use substitution method, well, okay, it's in the name. The same thing we did with the elimination method is that we have to get rid of one of the letters first, because we cannot solve equations with 2 or more unknown letters, right? So any equations, you have to get rid of one of them first by whatever means you want to, whether that's elimination or substitution. Then you can solve the equation with whichever letter is left. So in this case, when we use substitution, basically, let's say I'm going to label them equation 1 and equation 2 again. I'm going to be having a look at my two equations and decide which one would be easier to substitute into the other one. In this case, it's pretty obvious. The second equation has already got y as the subject, right? So that means I can say, okay, y is the same thing as x plus 3. So for example, in this case, I would substitute equation 2 into equation 1. And what that means is wherever it says y, I'm going to replace it with x plus 3. So equation 1, we've got x plus y equals minus 1. So I'm going to write x plus, now instead of y, I'm replacing it with the equivalent, with what y is the same as. Y is the same as x plus 3. So instead of writing y, I can just replace that with x plus 3. Obviously still equals minus 1. Okay, so I've substituted equation 2 into equation 1. It's up to you which equation you want to substitute into which. It doesn't matter which way around you do it. It's just in this case, it was pretty obvious that one would be easier than the other. So you can see now I've got that whole aim of the game is that I've got only x's, and obviously numbers, but just in terms of letters, the only letter I have is x in this equation. That's perfect. I've effectively got rid of the y temporarily, haven't I? So now all I need to do is solve this equation. Okay, well I'm going to start by collecting the like terms because I've got x plus x. So that can simplify to 2x, can't it? I still have plus 3 equals minus 1. This might look a bit more familiar to you now. It's just a normal equation, isn't it? So I'm going to solve it. I need to get x on its own. So I'm going to move the 3 first. And because it's plus 3, I have to subtract 3. I have to do the opposite, don't I? So 2x, we've cancelled out the 3 equals minus 1. Take away another 3. Be careful with your negatives here. This is just going to get more negative, isn't it? Minus 1, take away another 3 is minus 4. Okay, perfect. Now the last thing is I just need to divide by 2 on both sides to get 1x. So I'm just going to put it here. 2x divided by 2 is obviously just 1x. And minus 4 divided by 2 is minus 2. Perfect. There we go. I've got my first letter. Now with simultaneous equations, you know by now that we have to find both, don't we? We have to find x and y. It doesn't matter which one you find first or second, as long as you get both what is x and what is y. So now that we found x, that's the substitution part of the method. The second part, when you go to find the other letter, is the same with the elimination method, okay? Same thing. The only thing that changes is this first part. So now that I know that x is minus 2, I can kind of substitute that back in as I would with the other method. You just look at your original two equations and you choose, would I rather put x into equation 1 or 2? It doesn't matter, you just have to choose which you prefer. Personally, I would prefer equation 2 because I've already got y as the subject and I'm going to try and find y, aren't I? So I don't have to rearrange anything. So I'm going to sub x equals minus 2 into equation 2. So y equals, now where it says x, I'm going to write minus 2 instead, plus 3 is the equation. I don't even need to rearrange that, do I? I just need to literally do minus 2 plus 3, so y equals 1. There we go. I've solved my simultaneous equations. So that's the substitution method. You might think that seems easier. If you do, you can choose to use this one. It really doesn't matter which one you use. I think it was easier because it was laid out this way, but we're going to look at some harder questions where it's not laid out as straightforward as this. So let's look at the next question. As you can see, I haven't currently got either of my equations with either x or y as a subject. So I kind of have this additional step at the start where I need to create that scenario, don't I? I need to have either x equals something or y equals something. I'm going to have to rearrange one of my equations. Now again, it's not right or wrong. You can choose whichever of the two equations you want to rearrange. Again, in this case, I would say equation 2 is easier to rearrange because let's say I could make y the subject. That's also another decision. You can make x the subject or y the subject. It literally just depends what you want. In this case, I'm going to look at equation 2 and I'm going to make y the subject. The reason being is because to make y the subject, all I have to do is add x. That's it. Simple as. Whereas if I were to do equation 1, if I make y the subject, I'd have to subtract 2x. Okay, fine, but then I've got a load of negatives, right? Or if I were to make x the subject, I'd have to subtract y and divide by 2, and then you get a bit messy. So I'm always going to try and choose the path of least resistance, right? The easiest way to do it. So I'm going to rearrange. This is an additional step in this case. Rearrange equation 2 to make y the subject. So as I said, to make y the subject, all I need to do is move the x. Because it's currently minus x, I have to add it. I have to do the opposite. So I've got y equals x plus 2. That's still the same equation. I've just rearranged it, haven't I? Now I can carry on with exactly what I did before. So now I can substitute this into equation 1. Obviously, if you rearrange equation 2, you have to substitute it into equation 1, right? You can't rearrange it and substitute it into itself, okay? So I'm going to rearrange it and substitute it into the other one. So this is still equation 2, isn't it? I've just rearranged it. Equation 2 into equation 1. So I've got 2x, that stays the same, isn't it? Because I'm replacing the y. Plus just y, so just, instead of y, I'm writing x plus 2 equals minus 13. There we go. Now I'm going to bring it up here. Now I just have to solve it, don't I? So again, I'm going to collect the like terms. I've got 2x plus x, so that's 3 lots of x, 3x. Plus 2 equals minus 13, and then we're just going to solve it. So minus 2 on both sides because it's currently plus 2. So 3x equals minus 13, take away another 2 is minus 15. It's going to get more negative. And divide by 3 to get just x. Okay, so minus 15 divided by 3 is minus 5. Perfect, we've got one of the letters. Okay, the hardest bit is the first bit, right? The hardest bit is getting the first letter. Once I've got the first letter, getting the second one is then easy, isn't it? I'm going to take x as minus 5. And again, I'm going to choose one of my two equations. Which one do I want to substitute it into? Now, in this case, personally, I would substitute it into the rearranged version of equation 2. It's still equation 2, still the same thing. I've just rearranged it. The reason being is because if I've got x and I'm trying to find y, I'm going to have to rearrange it either way, aren't I? So I might as well use the rearranged version that I've already got. So sub x equals minus 5 into equation 2. So we've got y equals, now where it says x, I'm going to put minus 5 in this case, plus 2. So I've just substituted it into this one, okay, just so you can see where that's come from. And now I don't even need to rearrange it, do I? I just need to solve it. So minus 5 plus 2 is minus 3. There we go, I've solved my equation again. X is minus 5, y is minus 3. So I just had an extra step at the start, okay? So it was a little bit longer than the first example. So let's look at our first question. We're starting off with linear simultaneous equations. Okay, so this is, as I said, for both tiers, but mostly focusing on foundation tier. Linear is when we have straight lines, basically, isn't it? If you look at the equations, the highest power is just 1, right? X to the power of 1, y to the power of 1. They basically create a straight line graph equation. Obviously, it just looks like it's rearranged, isn't it? The straight line graphs, linear graphs, are written in this format, y equals mx plus c, but it could be rearranged. So you can see this. It has all the components, they've just rearranged them. So it says, using the graph, solve the simultaneous equations. They list them here. They're both drawn for you, right? You've got each equation is each different line on the graph. And normally this will be a couple of marks and they won't really give you any space for working out. Okay, so the two hints here is the fact that it says using the graph, and the fact that on your actual exam you won't see much space to do any working out. So if anything, we don't really even need to look at these equations for this one because it's already drawn for us. All we need to do is look at the graph. Now, simultaneous equations, we've said before, is where you have the x value for both equations is the same number. So we're trying to find what is x. Well, it should be the same number for both equations. And the same with the y, okay? The y is the same number for both equations. So x is the same here, y is the same here. Now, if you think about the graph, we're basically therefore looking at somewhere on the graph where both lines share the same x and the same y values. Now, it has to be at the same time. So really, the main thing about this graph I'm looking at is where do they intersect? Where do they cross over each other? Because that point, exactly in the middle here, is where they both share the same x coordinate and they both share the same y coordinate. Okay, coordinates, values, same thing, right? They're still just what is x as a number, what is y as a number. So all you need to know and remember is that if you get this question, just look on the graph, where do they cross, read off the x, read off the y. Okay, so you can see here we've got x is 1 and y is 3. Now, having done linear simultaneous equations, hopefully you would have seen the first two videos, you'll know that you only get one value for x and one for y. So that would be your answer, literally. It's literally as simple as that. You just have to know what you're looking for, right? Now that you know that, every question should be really straightforward, some easy marks to gain in your exams, okay? So let's look at another one. Again, exactly the same question, we just have different equations. So using the graph, solve the simultaneous equations. So you've got two here. They've drawn them for you already. So again, they've done the hard work for you. So I'm looking for where do they have an x value and a y value in common? Well, again, like I said before, it has to be where they intersect. So I'm looking, and sometimes you might want to use your ruler and draw some lines just so you can see exactly where it is, because this one we're going to have decimal answers, but you only need to look for one decimal place, okay? It's not like you have to really look more specifically than that. Okay, so you can see there we've got the x. So if I have a look, just double check, because the way I guess they can make it harder or a little bit more complicated is the scale of the graph. So just be really careful. We've got 2 here, 3 here. It's clearly right in the middle. Okay, so that is going to be 2.5. And then the same for the y. I'm going to draw a line across. Okay, we can see that again. We've got 0 and -1, so that's pretty much halfway. I just haven't drawn the line exact. So that's minus 0.5. Now also be careful, because it can be quite easy to think, oh yeah, that's 0.5 and forget the fact that it's negative, okay? So definitely don't forget to check, okay, I've got the numbers, but are my answers positive or negative? So in this case, our solutions are x is 2.5 and y is negative 0.5. So thanks for watching this video. That is everything you need as a foundation tier student for the topic of simultaneous equations. Make sure to like and subscribe and leave down below any questions or comments you might have.